In communications and information processing, code is system of rules to convert information such as a letter, word, sound, image, or gesture into another, sometimes shortened or secret, formal representation for communication through a channel or storage in a medium. An early example is the invention language, which enabled a person, through speech, to communicate what he or she saw, heard, felt, or thought to others. But speech limits the range of communication to the distance a voice can carry, and limits the audience to those present when the speech is uttered. The invention of writing, which converted spoken language into visual symbols, extended the range of communication across space and time. The process of encoding converts information from a source into symbols for communication or storage. Decoding is the reverse process, converting code symbols back into a form that the recipient understands. One reason for coding is to enable communication in places where ordinary plain language, spoken or written, is difficult or impossible. For example, semaphore, where the configuration of flags held by a signaler or the arms of a semaphore tower encodes parts of the message, typically individual letters and numbers. Another person standing a great distance away can interpret the flags and reproduce the words sent. Theory. In information theory and computer science, a code is usually considered as an algorithm which uniquely represents symbols from some source alphabet, by encoded strings, which may be in some other target alphabet. An extension of the code for representing sequences of symbols over the source alphabet is obtained by concatenating the encoded strings. Before giving a mathematically precise definition, we give a brief example. The mapping is a code whose source alphabet is the set and whose target alphabet is the set. Using the extension of the code, the encoded string 0011001111 can be grouped into code words as 0 a euro 011 a euro 0 a euro 01 a euro 011, and these in turn can be decoded to the sequence of source symbols ACABC. Using terms from formal language theory, the precise mathematical definition of this concept is as follows: let S and T be two finite sets, called the source and target alphabets, respectively. A code is a total function mapping each symbol from S to a sequence of symbols over T, and the extension of to a homomorphism of into, which naturally maps each sequence of source symbols to a sequence of target symbols, is referred to as its extension. Variable length codes. In this section we consider codes, which encode each source character by a code word from some dictionary, and concatenation of such code words give us an encoded string. Variable length codes are especially useful when clear text characters have different probabilities. See also entropy encoding. A prefix code is a code with the prefix property there is no valid code word in the system that is a prefix of any other valid code word in the set. Huffman coding is the most known algorithm for deriving prefix codes. Prefix codes are widely referred to as Huffman codes, even when the code was not produced by a Huffman algorithm. Other examples of prefix codes are country calling codes, the country and publisher parts of ISBNs, and the secondary synchronization codes used in the UMTS WCDMA3G wireless standard. Kraft's inequality characterizes the sets of code word lengths that are possible in a prefix code. Virtually any uniquely decodable one-to-many code, not necessarily a prefix one, must satisfy Kraft's inequality. Error-correcting codes. Codes may also be used to represent data in a way more resistant to errors in transmission or storage. Such a code is called an error-correcting code, and works by including carefully crafted redundancy with the stored data. Examples include Hamming codes, Reader Euro Solomon, Reader Euro Muller, Walshaw Euro Hadamard, Boosie Euro Shawad Huria Euro Hodgkingham, Turbo, Gallet, Gopper, low-density parity check codes, and Sparshia Eurotime codes. Error-detecting codes can be optimized to detect burst errors, or random errors. Examples: codes in communication used for brevity, a cable code replaces words with shorter words, allowing the same information to be sent with fewer characters, more quickly, and most important, less expensively. Codes can be used for brevity. When telegraph messages were the state of the art in rapid long-distance communication, elaborate systems of commercial codes that encoded complete phrases into single words were developed, so that telegraphers became conversant with such words as BYOXO, lyre, BMULD, or AYYLU. Code words were chosen for various reasons: length, pronounceability, etc. Meanings were chosen to fit perceived needs: commercial negotiations, military terms for military codes, diplomatic terms for diplomatic codes, any and all of the preceding for espionage codes. Codebooks and codebook publishers proliferated, including one run as a fund for the American Black Chamber run by Herbert Yardley between the First and Second World Wars. The purpose of most of these codes was to save on cable costs. The use of data coding for data compression predates the computer era. An early example is the telegraph Morse code, where more frequently used characters have shorter representations. Techniques such as Huffman coding are now used by computer-based algorithms to compress large data files into a more compact form for storage or transmission. Bletchley Park. Bletchley Park is an estate located in the town of Bletchley, in Milton Keynes, Buckinghamshire, England, and is run by the Bletchley Park Trust as a heritage attraction. During the Second World War, Bletchley Park was the site of the United Kingdom's main decryption establishment, the Government Code and Cipher School, where ciphers and codes of several Axis countries were decrypted, most importantly the ciphers generated by the German Enigma and Lawrence machines. The place was known as BP to the people who worked there. 1, 2, for the many members of the Women's Royal Naval Service who worked at Bletchley Park, their posting was to HMS Pembroke v. Character Encodings. Probably the most widely known data communications code so far in use today is ASCII. In one or another version, it is used by nearly all personal computers, terminals, printers, and other communication equipment. It represents 128 characters with 7-bit binary numbers, that is, as a string of 7 ones and zeros. In ASCII, a lowercase a is always 1,100,001, an uppercase a always 1,000,001, and so on. There are many other encodings, which represent each character by a byte, integer code point or a byte sequence. Genetic code. Biological organisms contain genetic material that is used to control their function and development. This is DNA, which contains units named genes that can produce proteins through a code in which a series of triplets of 4 possible nucleotides are translated into one of 20 possible amino acids. A sequence of codons results in a corresponding sequence of amino acids that form a protein. Gar paragraph del code. In mathematics, the Gar paragraph del code was the basis for the proof of Gar paragraph del's incompleteness theorem. Here, the idea was to map mathematical notation to a natural number. There are codes using colors, like traffic lights, the color code employed to mark the nominal value of the electrical resistors or that of the trash cans devoted to specific types of garbage. In marketing, coupon codes can be used for a financial discount or rebate when purchasing a product from an internet retailer. In military environments, specific sounds with the cornet are used for different uses, to mark some moments of the day, to command the infantry in the battlefield, etc. Communication systems for sensory impairments, such as sign language for deaf people and Braille for blind people, are based on movement or tactile codes. Musical scores are the most common way to encode music. Specific games, as chess, have their own code systems to record the matches. Cryptography. In the history of cryptography, codes were once common for ensuring the confidentiality of communications, although ciphers are now used instead. C code. Secret codes intended to obscure the real messages, ranging from serious to trivial, can be any kind of imaginative encoding: flowers, game cards, clothes, fans, hats, melodies, birds, etc., in which the sole requisite is the previous agreement of the meaning by both the sender and the receiver. Other examples of encoding include: encoding is a basic perceptual process of interpreting incoming stimuli. Technically speaking, it is a complex, multi-stage process of converting relatively objective sensory input into subjectively meaningful experience. A content format is a specific encoding format for converting a specific type of data to information. Text encoding uses a markup language to tag the structure and other features of a text to facilitate processing by computers. Semantics encoding of formal language A and formal language B is a method of representing all terms of language A using language B. Electronic encoding transforms a signal into a code optimized for transmission or storage, generally done with a codec. Neural encoding is the way in which information is represented in neurons. Memory encoding is the process of converting sensations into memories. Television encoding, NTSC, PAL and SECAM. Other examples of decoding include decoding, decoding methods, methods in communication theory for decoding code words sent over a noisy channel, digital signal processing, the study of signals in a digital representation and the processing methods of these signals, digital to analog converter, the use of analog circuit for decoding operations, word decoding, the use of phonics to decipher print patterns and translate them into the sounds of language, codes and acronyms. Acronyms and abbreviations can be considered codes, and in a sense all languages and writing systems are codes for human thought. International Air Transport Association airport codes are three-letter codes used to designate airports and used for bag tags. Station codes are similarly used on railways, but are usually national, so the same code can be used for different stations if they are in different countries. Occasionally a code word achieves an independent existence while the original equivalent phrase is forgotten or at least no longer has the precise meaning attributed to the code word. For example, 30 was widely used in journalism to mean end of story, and has been used in other contexts to signify the end. See also, asemic writing, equipment codes, quantum error correction, semiotics, references.